All right, today we're going to talk about scientific notation. Scientific notation is when you take a normal notation number and then you can convert it into scientific notation. Okay, you'd want to do this if you have a number that is very large or very small. By converting it into scientific notation, it makes it much more convenient and easier to work with. I'm going to write some examples here of some kind of practice, and then we're going to take a look at the rules, and then we'll apply some rules to these practice examples. So the first number we're going to look at is 46. Very easy. You generally wouldn't want to put this number into scientific notation, but you can take any number and put it into scientific notation. Then a more practical example would be this next number here. Has a whole bunch of zeros in the beginning and then some digits at the end. This is a very small number, and it would be perfectly appropriate to put this into scientific notation because it would be more convenient, it would take less time to write it, and it would be easier to talk about. Another example, instead of having zeros at the beginning of some digits, you'd have some zeros at the end of some digits. So we could do this example. So this is an exceedingly large number. It can also be put into scientific notation and would be very convenient to have in scientific notation because it takes a while to write it down. There's a whole bunch of zeros, and it's even very difficult to say. And a fourth example here. Okay, we're doing this example because it has an example of multiple different types of zeros, and zeros are important when you are moving things from normal notation into scientific notation. So let's talk about the rules first for how you take a number in normal notation and move it into scientific notation. The first rule, there's three rules. The first rule is that you write the digits that matter so that there's one digit to the left of the decimal. So the important thing here is the digits that matter. In any number, there's two types of digits. There are digits that are 0 and there's digits that are not 0. So let's first address the non-zero digits. These digits will always matter. So if you have a digit that is not 0, rule number 1 says you need to write it down. Now that leaves us with 0 digits. 0 digits will sometimes matter. And the way that you'll know that is by understanding what types of zeros there are. So the way that we're going to describe the types of zeros is we're going to kind of draw the anatomy of a number here. So let's say you have every number can have some zeros in front. Maybe there's 5 zeros in front. Maybe there's some digits here, some non-zero digits. Maybe there's a decimal here, so decimal place. And then maybe there's more non-zero digits here. Maybe this number continues and there are some zeros in the middle of it, and they are between additional non-zero digits. Maybe lastly, at the end of this number, there are some more zeros. We're doing it like this so that we can illustrate the three types of zeros that you can experience. You can experience these zeros on the left of a number here. You can experience these zeros here. They're kind of sandwiched between non-zero digits. So we like to call these sandwich zeros. And then we have the zeros on the right, and we call these right zeros. So you have left, sandwich, and right type of zeros. Now some of these zeros will matter, some of these zeros will not matter. If you have left zeros over here, these zeros will never matter. Sandwich zeros in the middle, if it's a middle zero, it will always matter. And then over here, the last type of zero, right zeros, they will sometimes matter. And the criteria for these mattering over here are if there is a decimal located someplace in the number. So in this example here, the anatomy of just a general number, we showed that a decimal was present. So if a decimal is present, we can say, check, these guys matter. However, in other examples, there may not be a decimal in this case over here. In a number. So for example, if there was a 0 at the end of this 460, but there is no decimal after the 0, that would be a right-hand 0 that does not have an expressly written decimal in the number, in which case that particular 0 would not matter. So if there is, we're just going to draw a decimal and kind of an X through it. And if there is no decimal, it does not matter. That 0 does not matter. Okay, so the right ones are kind of the most difficult because you have to analyze the number. If you see a decimal written in the number, then those zeros will matter. If there is no decimal expressly written, then those zeros do not matter. All right, step 2 is very easy. You just write times 10. And then the last step in turning a normal notation number into a scientific notation number is you need to determine the sign and the value for the exponent of the times 10. Okay, the way that you determine the sign is through a number line. So for example, here we have I'm going to draw a number line here. So there's 0. The values on a number line over here are going to be positive in nature. So these are positive values on a number line, whereas the values over here on a number line, these are negative values. Okay, and so that will help us in determining the sign. So let's go up and look at our examples and use these rules to turn them into scientific notation values. All right, for 46, I want to write that in scientific notation over here. It says write the digits that matter so that there is one digit to the left of the decimal. So both 4 and 6 are not 0. So I'm going to come over here and write 4 and then 6. And then I need to add a decimal. And I'm going to put the decimal between the 4 and the 6. That means this decimal, there is one number to its left. The 4 is to its left. Okay, so number 1 is done. Number 2, it says I need to write times 10. So we're going to write times 10. And then the last rule says determine the sign and the value of the exponent. So essentially what I did was I took the 4 and the 6 and I put a decimal between the 4 and the 6. In order to return the decimal to where it was implied, I need to move it in the right direction one time. So I need to move it in the right direction. So those are positive values on the number line. So the sign is positive, and I need to move it one single time. So we are going to have an exponent on the 10 of positive 1. We don't write the positive, but if it's negative, we do write the negative. Okay, so 4.6 times 10 to the 1 would be 46 in scientific notation. All right, let's come down here and let's do the same thing. I see 8, 6, and 1. Those are non-zero, so I'm going to write 8, 6, and 1. And now I need to figure out what about these zeros here. Well, these zeros, they are on the left of this number, so they are all left zeros. So these will never matter. So these left-hand zeros I do not need to write down. So they do not need to be written in front of the 8, 6, and 1. But I do need to place a decimal between the 8 and the 6. That means the 8 is the single digit that is on the left of the decimal. And then we're going to write times 10. And now I need sign and exponent value. So basically my decimal went here between the 8 and the 6. And now I need to move this decimal 1, 2, 3, 4, 5, 6 times, and I'm moving it in the left direction. I'm moving it to the left on a number line. Those are negative values, so to be negative is the sign. And what was it? I moved it 6 times. So the exponent would be negative 6. 8.61 times 10 to the minus 6. All right, let's move to this one over here. Non-zeros, always important, so I'm going to write 1, 4, 5, 4. And now I have to figure out these zeros. Are they important or are they not important? What kind are they? They're definitely not on the left. They're definitely not sandwiched between two non-zeros, so they are right zeros. So these zeros are on the right of the number. And I do not see a decimal, so there's no decimal in there, so those zeros do not matter. These zeros do not matter. I'm not going to write them down. Okay, I do need to put a decimal between the 1 and the 4. And then step 2 says write times 10. Now my decimal went between the 1 and the 4. The implied decimal is over here by this 0. So I need to move that decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. And I'm moving it in the positive direction, and I moved it 11 times. So the exponent will be positive 11. 1.54 times 10 to the 11 is how you would write that value in scientific notation. All right, now we come to this last one here. This last one has all 3 types of zeros. So definitely the 4 and the 3 are not 0. And then what connects the 4 and the 3 together is this sandwich 0 in the middle here. So what we're going to do is we're going to write 4, 0, 3. Sandwich zeros always matter. So we're going to write that down definitely. Now what about these zeros over here? These zeros are on the left, so they never matter, so I'm not going to write these zeros down. What about this 0 over here? This 0 is on the rightmost of the number, so these sometimes matter, and they matter when there is a decimal in the number. And so I can see here that there is a decimal expressly written here, so this 0, check, it does matter. So I do need to write that 0 down next to the 3. I need to put a decimal, so there's 1 digit to the left, so the decimal goes between the 4 and the 0. I need to write times 10, right? Times 10, and my decimal went between the 4 and the 0, so I need to move my decimal 2 times to the left, so the exponent would be negative 2. Negative because I'm moving it in the left direction, so it's negative, and 2 because I moved it 2 times to match. So 4.030 times 10 to the minus 2 would be this value written in scientific notation form. All right, guys, that's all on scientific notation.